In this section, we will learn about one of the laws called Boyle's Law. Boyle's Law deals with pressure and volume. To understand Boyle's Law, let's take a look at an example that you may have encountered. What happens when you squeeze a balloon? When you squeeze a balloon, you're actually reducing its volume, and as you reduce its volume, the pressure is going to increase. Sometimes the pressure increases so much that it will burst because the balloon cannot handle the pressure. So what we just talked about is how when we change one property, in that case volume, it can cause a change in another property, in that case pressure. There is a relationship between those two. And in gas laws, there are two types of relationship. One is called inversely, and the other is called directly proportional. So what do you think? Is volume and pressure in that example we just did, are they inversely related or directly related? Based on the definition that we have already looked at, directly means if one increase, the other increase. If one decrease, the other decrease. So that's not a direct relationship between volume and pressure, correct? When you decrease the volume, the pressure increase. So that was an inverse relationship. Let's take a closer look at Boyle's law again. So to see Boyle's law at work, we have here an example of a container of gas. There are gas molecules in here bouncing around, exerting a certain pressure on this container. In this state, we have measured that the volume was 4 liters and the pressure is 1 atmosphere. Okay, imagine that you have a piston now that can move up and down. Imagine it going down so that you have decreased the volume. What do you think how that would affect the pressure of the new state? Keeping in mind that the temperature has not changed and the amount of gas particles or the moles of gas in there have also not changed, how would the pressure change? Now think about this in kinetic molecular theory. If there is less space, less volume in the container, but the molecules are still bouncing around at the same rate, wouldn't they bounce against the wall at a more frequent rate? They will see the wall much faster than it was in a larger space. Since they are bouncing against the wall faster at a faster rate, they exert more force on the wall. Because of that, the pressure would increase, right? So that's using kinetic molecular theory. And so if we were to measure this, actually, this volume went down to 2 liters, so it went down in half, and the pressure went up. It went up by twofold to 2 atmosphere. Okay, so that's the relationship between volume and pressure. If we take a look at this from a math perspective, we can try to see how they relate. So if we took pressure and volume at state 1 and multiply each other, we would get a certain value. In this case, it was 4 atmospheres liter as the unit. And again, if we took in state 2, taking the pressure and the volume, we multiply them together in the same way, we would get 4 atmospheres liter. What do you notice, right? Is a same number. So from that, we say that anytime you take pressure, you multiply it by the volume, you will get the same number. In this case, we call it a constant. And that is true as long as N, which means the number of moles, and T, which means temperature, is constant. It does not change. That means that if you took pressure and volume from one state, you multiply it, it will be same as pressure multiplied by volume of another state, and pressure and the volume multiplied at another state, so on and so forth. So from that, we can simplify that relationship saying that P1 times V1 is equal to P2 times V2. In this case, the subscript 1 represents the state 1, the subscript 2 represents the state 2. So this is an equation that you will use often to solve for Boyle's law. So let's have a checkpoint. Let's see if you understand Boyle's law conceptually. When your lungs expand and if the temperature and amount of gas in your lung is constant, how has pressure changed? Okay, so it says, again, temperature and N amount of gas is the same, so then we can use Boyle's law. So when your lungs expand, meaning the volume increase, pressure must decrease. The answer would be A. Very good. So I asked this question to kind of prime us to explain how breathing actually works. Breathing is actually just Boyle's law in action. Okay, so what happens when you breathe? When you breathe, your muscle contract. As soon as your muscle contract, now there's more space for the rib cage to expand, and therefore the lungs also expand. Expansion of the lung is an increase in volume of the lung. As you increase the volume of lung, therefore the pressure in your lung will decrease. And air will always flow from a region of high pressure into the region of low pressure. So if the pressure in your lungs is lower than outside, then air from the outside will flow into your lung. Okay? How about when you expire, when you breathe out? How does that work? Okay, so in the opposite case, right? So instead of muscle contracting, now your muscle relaxes. As soon as your muscle relaxes, it takes up space, and if it takes up space, the rib cage will collapse down, therefore decreasing the volume of your lung. Now, if there's a decrease in volume, there must be an increase in pressure, right? So in the same way, now that your pressure is higher in your lungs than it is on the outside, air will flow from the high pressure in your lung. So let's do an example using Boyle's law. This example reads, Freon 12, which has a formula of CCl2F2, was used in the refrigeration systems. What is the new volume of an 8.0 liter sample of Freon gas initially at 550 millimeter of mercury after its pressure is changed to 2,200 millimeters mercury at constant temperature and moles? So when you do these kind of questions, just ask yourself what is known and what is not known. We know that this is a relationship. We know that they're trying to ask us about pressure and volume, right? So there has to be some P1 or P2 and V1 and V2. So if I were to go back and read this, it says what is the new volume? So new volume is what we need. So we do not have the new volume, the V2. Of an 8.0 liter sample, right? So originally it was 8.0 liter, so that's in V1. And the gas was initially at 550 millimeters of mercury. That's its pressure initially. So 550 millimeters mercury. And by the end of that, it has changed to 220 millimeters of mercury. So with this information, we just plug it into our equation. And our equation states that P1 times V1 is equal to P2 times V2. We then rearrange this equation in order to solve for what we need, in this case V2. How do you isolate V2 to be on one side only? We have to divide both sides by P2. Right? So P2 goes away. V2 then is equal to P1 times V1 divided by P2. Let me rewrite that over here. So then V2 is equal to P1 is 550 millimeters of mercury times V1, which is 8.0 liters, divided by P2, which is 2,200 millimeters of mercury. Again, unit analysis tells us that the millimeters of mercury will cancel, giving us units of liters. You do this on your calculator, and what do we get?
550 times 8 divided by 2200.
Giving us 2.0 liters. Right? At the end of all these problems, make sure that your answers make sense, because you already know what Boyle's law says. Boyle's law says the relationship between the pressure and volume is inverse, right? So if originally you were 550, you increased pressure to become 2200. Therefore, the volume, again, the pressure have increased, so the volume must have decreased. So it does make sense that it was 8, now it decreased to 2. So at least it is in the right direction. Let's do one more checkpoint. This question reads, cyclopropane is a general anesthetic. A 5.0 liter sample has a pressure of 5 atmosphere. What is the volume in liters of the anesthetic given to a patient at a pressure of 1 atmosphere if the temperature and moles are constant? So if you see that temperature and moles are constant, you should use Boyle's law. Very good. So Boyle's law states that pressure and volume are related. So let's figure out what our pressure is and what our volume is. Read this question again. A 5.0 liter sample, liters, so that's volume, has a pressure of 5 atmosphere. It has 5 atm. What is the new volume? So we don't know the new volume. If the pressure is at 1 atmosphere. Okay, so we say to ourselves we want to calculate this. So the equation is P1 times V1 is equal to P2 times V2. To solve for V2, again, we divide both sides by P2. P2 will cancel each other out, giving us this equation. Plug things in. P1 is 5 atmosphere. V1 is 5 liters. P2 is 1 atmosphere. Okay? Atmospheres and atmospheres cancel each other out, giving you liters in the end, which is good. So 5 times 5 divided by 1 is 25 liters. Again, making sure our answer makes sense. Our pressure decreased, and then pressure and volume is inversely related. So volume must increase, and it did increase. So the answer there is 25, which is letter B.